Hello and welcome to Astronomy Answered Simply. I'm your host John, where I answer everyday astronomy questions on Quora in a simple, easy to understand with very simple explanations that we can dive into later, but for now we keep it easy and simple. So today's question is, what is actually happening inside a star's core? So inside the core of stars are just literally big balls of gas with a few heavier elements that helped, start the gravity for the gas to condense around. So great big balls of hydrogen is basically what a star is, hydrogen and helium. Stars get so much mass, they gather so much gas that they get hotter and hotter and denser, and there's more and more atoms packed into a tinier and tinier space, that eventually the pressure gets to a point where it gets so hot and so much pressure, the electrons orbiting the individual hydrogen atoms stop repelling each other, and eventually the two protons and neutrons, the two cores of these atoms, combine. They fuse in a process known as nuclear fusion. So the super simple explanation is nuclear fusion is what happens in the core. This is different from what happens in nuclear reactors, which is nuclear fission, which is the decay of very, very, very dense, heavy elements that are unstable and release energy. Different topic, different video. But nuclear fusion is the process by which elements combined and fuse, hence fusion, into one another, into heavier elements. We can go into a lot of detail about the nuclear fusion process, but it's hydrogen turning into helium, helium turning into beryllium, hydrogen and helium combining to form lithium, helium combining to form beryllium, beryllium, hydrogen, helium, various combinations of those elements as the star burns through all its hydrogen and burns through its helium. Heavier and heavier elements get combined and created, like boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, silicone, all the way up through the periodic chart until you get to iron. Once you get to iron, depending on the size of the star, it can keep fusing, but fusion is basically about to stop. Iron is so dense that once you have iron created in the core, the force of iron is so dense and has so much mass when it's created. Once there's enough iron, there's pushback on the fusion process, and fusion will basically stop, causing the core of the star to collapse in on itself and cause the star to basically explode. Now that explosion creates massive release of energy. Huge. We're talking as much energy as our sun puts out in an entire 5 billion years. I mean, huge amount of energy. And inside that star, as that pressure collapses and the pressure pushes back from this iron core, a pressure wave builds up and expands out in the energy that's released in this process. And that compression and explosion, it pushes all these elements out. But because of the massive energy and the massive pressure, that's where you get all the heavier elements above iron. Every single one of those. Or at least most of those. There's a cutoff point where some of those are not even able to be created in the cores of stars in supernova, which is the type of explosion we're talking about. But those get created in a different kind of combination, like between neutron stars and black holes. When they combine, we're talking the most dense materials in the universe just smashing into each other with unimaginable power. And those explosions are so fast because neutron stars are the leftover cores of supernova, and black holes are the leftover cores of extremely large supernova. So the basics of what happens in the core of a star is really nuclear fusion. Now, during the fusion process, one of the elements or one of the particles that emitted is photons, which is the light we get from the sun. All that light is released when elements fuse. Now, funny side note, it can take upwards of 300,000 years from the light to get from the core of the sun, where it's fusing into hydrogen into helium, to the surface of the sun, where it then travels through space in 8 minutes to get to the Earth. Yeah. It's so dense that it takes light hundreds of thousands of years, because it's so much matter and so much density that the light just bounces around and it takes forever to move from one element to another, and there's so much material blocking its way that it's absorbed and redispensed and absorbed and redispensed and just bounces from electron to electron and around until finally it hits the surface hundreds of thousands of years later and travels through the universe forever. However, for that photon, because of relativity, the photon experiences no time. From when it leaves the sun to when it impacts the Earth, as far as the photon's concerned, it's instantaneous. For us, we see it take 8 minutes from the Earth. It takes hours to reach the outer solar system. But I thought that was an interesting little tidbit. So basically, nuclear fusion, that's what's responsible for every single element on Earth. All of us, we are the leftover remnants of stars. All of the elements in your body, all of the elements in my body, our computers, our desks, our houses, this whole planet, all are the result of nuclear fusion in the center of stars that are long gone. Thank you for watching. Feel free to let me know if you have any requests. Leave a question, leave a comment, ask for more details, ask for links. I'm here to help. I love to educate. And I love learning every day. I love to teach every day. Learn something new every day. Like, subscribe, recommend people, ask me if you want interaction with your class. Have a great day.